Hi, this is John Harrison from InsightVR.com. This is my PyCon 2008 presentation. I'm recreating the first few minutes as they were not recorded. When my talk was first accepted at PyCon, I of course looked up the how not to give a talk slides on the PyCon website and found that the number 2 sin of giving a talk is the abuse of laser pointers. This meant that my talk was going to be a bad talk. This talk will involve the use and abuse of laser pointers, and it will involve the use in ways that probably hadn't been imagined by Ivan. Some other things are going to happen that are pretty bad as well. I'm going to make a complete fool of myself at some point in the talk, and it's going to be okay for you to laugh at me. It's meant to be a little bit silly, and this is meant to be a fun talk. I'd like to talk a little bit about the inspirations for the projects. The first was the Graffiti Research Lab laser tag project, which I saw on the web, and I'm going to show you a short video clip of that now.
Whoa, pass me the laser beam, and make me wipe out the wicked and clean. Pass me the laser beam, and make me wipe out the wicked and clean. Them a come with them chopper, yeah.
Halloween was coming up, and so I wanted to do something Halloween-ish. So we've got another
Halloween, orange and black flavored marshmallows. With the sorry, but you gotta do it.
Anyhow, my kids think that I must have got a toenail caught in my throat is high comedy and the best thing ever, so I wanted to do something involving Marshy for Halloween. And so here's the concept, is I wanted to set up a laptop with a built-in camera in the garage, which is the PySight, and a projector, and project out onto a screen in the door of my garage, and then give people who came by for Halloween some sort of laser gun and let them shoot at Marshy in order to earn candy for Halloween.
All right.
And so I had a few things. I had a MacBook Pro, which has an PySight. I had a laser pointer from a discarded experiment 10 years previous to make some sort of Pink Floyd laser show, and I had a garage. I did not have a projector. I didn't have any sort of screen. I didn't know how to get at my PySight, and I didn't have any game to have people play, and I had no clue about PyCon, and in fact this was sort of a teach myself PyCon project. So the first solution that I found was PySight, which gives real easy access to PySight. It's a wrapper over the Cocoa sequence grabber. It's like 8 lines of code. It's incredibly simple, and it gave me bitmaps, one right after another, which is what I wanted. It also comes with PySight test. Confronted with Python and having to actually use this software, I was a little intimidated, but this is a real simple and functional PySight app, and I'll actually run it here for you. And so there's the test app. It lets you see what the PySight is currently seeing. And so there's an event loop in there, and I decided what I need to do to find my laser is look for red spots. And so there's a question, what is red? And so I came up with 2 tests. There's a first one that's real simple that I ran all the pixels through, and they're like 300,000 pixels in a 640 by 480 bitmap, and so it took a little while. So the first test is just look at how, in the RGB value of any given pixel, look at the R component of it and make sure that it's above a certain threshold, and it's adaptive, and so whatever the reddest thing it's seen so far, it keeps track of that, and you have to meet that threshold. A pixel has to be at least 2/3 of that value. But because it's an RGB tuple, it could be white and come up with a very high red value. So we had a second test which it only passed if the thing is actually red. So we have a redness is equal to the red value times 2 minus the green minus the blue. So if it's white, your score is going to come out as 0. If it's red and red, it's going to come out over 500. And so the pixel on the screen, or in the camera's view, I should say, anytime with the highest score on that second test is the one that I'm interested in. And if no pixel is red enough, then there were no results. So we just, every time we hit the buffer, we just loop through all the pixels looking for the reddest one, and then we pass that over to the game. Now there's a better way to do this, I think, which would have been to go through, look for a list of all pixels that were red enough, sort by redness, and then because there's going to be groupings around where the laser shows up, remove any pixels that are nearby, the reddest ones, and then just send a list out to the game, which would have given us the ability to detect multiple lasers at one time, but the game did not have that. And then another thing that I found was Pygame. Pygame comes with a demo program called aliens.py. It's basically a mediocre version of Space Invaders, but it gave me what I wanted. You move around with the arrow keys and shoot with the space bar, so I modified how the aliens moved and made it so it really doesn't matter if you move your little tank at the bottom or not, and changed the graphics from aliens to marshies. I made a big mistake while making this. I figured I would just go straight to the laser interface. That made testing rather tedious. I should have made it so mouse clicks would have killed Marshy while I was doing the development, and so I had to debug several things in parallel. If I had been smarter, I wouldn't have done that. So I had a game that worked, and I had something that would see lasers, and I had to link the two things together. And luckily, my brother Matt here, who owes a lot, I owe a lot of thanks for this project, knows more Python than I do, and showed me how to link up the two event loops that each program had with some global variables which kept track of some various things, and we'll get to why we need those in a second. But basically, if there's an X and a Y value for where the laser is at, and then there's a flag to say whether there actually was a laser detected or not, and then some values to use for calibration. There's some performance concerns that I had. Scanning through the 300,000 or so pixels, 30 to 15 times a second is kind of slow, and so I made some optimizations to try to make it workable but have decent performance. So I only actually do the scanning for the laser on every 5th frame. I use the calibration step, which we'll get to in a minute, to limit the area that the scanning actually occurs in. And I only scan every other line, and then on those lines I do scan every other pixel, so it only actually does 1 in 4 pixels, which sped it up enough to be workable. So we had to calibrate this. As you can imagine, and you'll see when I actually take the computer over and do the demo over here, you don't necessarily get a nice rectangular screen in your eyesight image. You actually get some odd trapezoid or, I don't know, any sort of 4-sided figure. And so I sat down with some graph paper and pencil and figured out a transformation that would take any 4 points for the corners and form an arbitrary transformation such that the shape could be whatever. And I thought, oh, this is going to be a pain to implement. So I decided just to try this dumbest thing I could think of first, and it worked well enough, and so that's what I stuck with, and I don't actually use a fancy transformer. And so the simple calibration is I put a dot that's red in the corner. The game actually has a calibration mode, so it shows red on the screen, waits for the eyesight to see it, and then puts a dot in another corner. And it saves the highest value, or topmost value, it sees the bottommost, leftmost, and rightmost. And so it knows basically where the screen is or what the game coordinates are. And so then we can apply these formulas here to transform between the coordinates that the eyesight's seeing and the coordinates in the game world. And so, and that works well enough for my purposes, and so I stuck with that. And so so basically in the game, it's going to throw up these 4 red dots. What the eyesight sees, it might be some sort of odd trapezoid. But we just basically, you can see the upper right there is determining both top and right. The upper left is actually not going to determine anything because it's not the topmost or the leftmost. The lower left is determining the left border, and the lower right is determining the bottom border. So there, there's some concerns about laser safety, which I'm going to go through before anyone starts shooting things. Lasers can in fact be dangerous. I don't know that much about them, but I know that you should not stare at them and turn them on. I got really low-powered ones for Halloween because I was going to hand them out to kids, and even so, I'm constantly batting the gun away from kids who are trying to look at it and see what the laser looks like. They were so anyhow, they're low enough power. The ones I got were supposedly low enough power that you could actually stare at them and not cause much harm. Most laser pointers, however, are about 5 milliwatts, which is enough power that if you purposely stared at it, you would hurt yourself. And in fact, I think the ones I'm giving out today are, well, they're weird ones from China, so who knows what power level they are. But they claim to be less than 5 milliwatts, but you could hurt yourself. Well, your blink reflex should protect you, but not if you stare at it. And I've got some links here for more information on laser safety if you're interested in the topic. I bought low-powered laser pointers at laserpointer.net. If you want to buy some, and I also bought some giveaway ones here that half of which went bad and aren't worth giving away. So I don't necessarily recommend that supplier. And then I bought actual just laser modules from Axis Laser Company, which has this unpronounceable URL that has nothing to do with Axis. And so I made, pointing a laser pointer at the screen isn't all that interesting, so I made laser guns for the kids to use. So this is the first one that I made, and it's just PVC that I bought at Home Depot, and I actually just stuck my 10-year-old laser pointer in here, and then taped its switch down, and then I have a little switch from Radio Shack that I soldered in there instead. And it's even got a non-working scope. And then I decided having a real Star Wars laser gun that makes sounds would be fun, and so I took the LED out of a $30, I guess this is a General Grievous gun, I don't know, from Target, and just stuck a laser module in there, and it just worked, which was nice. Opening this gun up is a real pain. You've got about 20 screws, and then this orange cap on the end, which is required for legal reasons so you don't get shot in Central Park or something. Is really hard to get off and wouldn't allow me to split the thing open. So anyhow, have fun taking those apart if you want to make one. So the results were, it works real well, and it was a hit at Halloween. We had sometimes a line of kids 20 deep in our driveway, and parents saying, "Come on, can we leave now?" And the kids screaming, "No." They're like, "Don't you want your candy?" No. It needs to be pretty dark. President Bush's idiotic new daylight savings time does not help with this. And so an hour more of darkness would have been nice. For my screen, I just used a $9.99 queen size flat sheet from Target and just clipped it to the top of my garage door when I had it open. The game's inherently multiplayer. If multiple people are shining multiple lasers at the screen at one time, it will pick up those lasers kind of not in a single frame, but in sequence. Generally, if you aim for a green part of Marshy, it's not likely to see him, so if you aim for a dark part, it works better. The response isn't as fast as I like on the Marshy game, and we'll see some solutions to that maybe in a second. And if you have a MacBook and you plug in a FireWire digital video camera in order to be able to zoom or whatnot, or just have a higher quality sensor, you can plug that in and it will just work with this software, which is kind of cool and unexpected. So I had some other ideas for what would be fun games. Missile Command would be cool. So I got as far as writing a PyCon version of Missile Command, but I haven't laser enabled it yet. If people are interested, maybe we could have a birds of a feather session in here tonight, maybe before Phil does his Galcon, and enable that and shoot at it with lasers or something. Whoa. It would be cool to do 3D games, but you need a way of moving your player in the 3D world. So I don't know how many of you have seen the Johnny Lee head tracking demo with the wiiMote and the IR lights, but that would be one way of moving around. If I used IR lasers instead of red lasers, that would allow for full color games, but you can't see them, so you'd have to aim better. Maybe you could use both red and IR lasers at once. Anybody have any questions before we start showing things? Okay. Most webcams actually pick up IR natively unless they're filtered, and so it would just work, it would kind of show up as red. Any other questions? Yeah?
Do you consider just processing the part that is marshy? Since you have your transform already, you should be able to translate from the Pygame representation of the rectangle into like what marshy is.
That's an excellent question. The game knows where marshy is. Can I just look for the laser where marshy is? I could do that. You'll see when it works, I'm actually recording anything that hits the screen, it makes a sound effect for having shot. And so that would work, but not as and would work better in some ways, but not as well. Yeah?
You don't actually have, even though you have multiplayer, you can't really keep track of individual scores.
Correct. It has no concept. It's really disconnected from the interface of interaction. Go ahead.
Your blink reflex is not sufficient to protect you from lasers. Very counterproductive.
Do you hear that? Do not stare at the laser. Your blink for nuts won't save you. So the more colors of lasers I introduce, the fewer I have to draw with, is my main concern. And that is the end of my giveaway lasers. I've got a few more for a session maybe at 7 p.m. tonight in this room.
Explain that about the draw with. What do you mean?
What's that?
What is this about you have to draw with?
I don't understand.
Two things. Draw with colors.
Oh yeah, I'm sorry. Because the camera is looking at the screen, if I've got using a green laser in order to shoot at the screen, that means I cannot use the color green in my palette for my game. You'll notice my games are pretty monochromatic. And that's because I can't use red. Okay, anything else? Okay, we will abandon the slides and get to the demo then. So, fortunately, Macs tend to come with photo booth, and so you can look and see if you're properly aligned. The key to alignment is just to make sure that the entire screen shows up in photo booth. And so we'll do that, and then we can quit photo booth, and then what did we do here? Wrong game. Here, we'll see if that. And so there's marching. We hit C to calibrate, and it's seeing those red things in the corner. And now, if people have lasers in the audience, don't shoot at me, but you're welcome to shoot at the screen. And you can see you can kill Marshy, and then those green target-looking things are actually where it has detected a shot, which was useful for debugging. And people have questions now that they've seen what it does, more or less? Okay, so
We're too absorbed playing.
okay. Well, if we can stop playing for a moment, I'm gonna set up. So we thought it would be cool to do a 3D game, which of course requires wiiMote head tracking. And so we use there's a wiiMote library for the Mac, and I had to seriously mutilate it to get it to work with PyCon, but was able to get that working. Let me kill it. And this will probably fail on the first try and work on the second, which is generally how the wiiMote stuff works. I built some safety glasses with batteries and LEDs on them. So I need to apply my alligator clips to my LEDs to get them turned on. Unfortunately, you cannot see that they're on because they're infrared and we don't see in that. But actually, one way to check is to just hold it in front of your eyesight, and your eyesight will, in fact, indicate that we'll see them as a bright light, so you can actually tell that you've wired them up correctly. And then, usually the the wiiMote doesn't connect properly on the first try. Yeah, that disconnected. So we quit. Yeah. Weird. I apologize for the flakiness of my Bluetooth. So we got a new calibration mode here, and we'll detect the wiiMote. And so now I'm going to start looking stupid. Got multiple glasses on. If I had, and so hopefully this will save me and I can move around. It's pretty busy, and hopefully people won't throw too much in our way. And now we can shoot Marcy to the and if you get to a building, here, you can jump. wiiMote has hardware tracking of 2 infrared points. Actually, it can do up to 4, but I'm only using 2. And so you can tell basically how far away someone is by the distance between the 2 points. You can track their left and right. I had tilting your head as doing something as well, and plus up and down to be able to jump or change the angle at which you view things. And then Travis at Enthought suggested yesterday, I was looking at his multi-touch demo, asking them how they track 50 points, and suggested using NumPy to process my image, which is what I finally did. So the first pass, looking for just red pixels, goes through with NumPy. So now it goes every single frame, every single pixel is being processed, and we are in fact returning a list of all pixels, so you can shoot this thing with 40 lasers at once, and it will detect all of them as long as they're far enough apart. I'm trying to think what else. There's weird bugginess in that there's a event loop for the wiiMote, there's an event loop for OpenGL, this is done in Piglet, and there's an event loop for the PySight, and they're all trying to access certain things at the same time, and so there's probably some sort of concurrency issues, I'm not exactly sure, but it works, well, every other time we run over this question.
Do you consider using something like Intel's OpenCV,
I became aware of that last week, and so I haven't really looked into it in any detail yet. Yeah, that's an excellent question. I didn't know about that until recently. The new stuff that we got going last night with NumPy seems to be fast enough to work. Oh, I'm sorry. If I've seen the Intel OpenCV libraries, and that would speed up the and go ahead. For the wiiMote, okay. So the question is, would any IR camera work? And the wiiMote is superior in that rather than giving you back an image of where your points are, it gives you coordinates for where your points are. So you don't have to do any vision processing for the data from the wiiMote. It's all handled for you. You just get the coordinates back in it. Got 2 minutes left. More questions? Been playing around with this at like 7 p.m. Show of hands. Anybody? Okay. Yeah, we'll have it here. Go ahead. It was a lot of fun. I actually programming Python every day for work now, and this was an excellent way to learn. There was some weirdness at first. Some of the self stuff is a little like annoying. I've got a few other minor gripes, but Also, and when you're programming in OpenGL, there tends to be, you want to indent your code organizationally rather than where you would put curly braces in Java or C, and that's impossible in Python, so that's a little sad, but that's okay.
Is this using Pygame?
The previous one was Pygame. I did this one in Piglet, actually. Is that it? I got one. Go ahead.
Someone else has another question.
Oh, I'm sorry. I missed it. Where's the question?
Oh, no, well, so I was wondering, like, how much previous experience you had, like, doing 3D rendering thingies, or, like, there's just, like,
Yeah, I've written stuff in OpenGL before. The question is how much OpenGL. This is actually a port of a partial port of a different game that I was working on like 5 years ago in C++. And so, yeah, but it wasn't a head track or anything like that.
We didn't know that.
Was there one up here? Okay, thank you very much. We'll see some of you guys.